When upgrading to a NEMA size 4 contactor, it's crucial to adhere to the National Electrical Code (NEC) clearance requirements. These requirements ensure safe operation and maintenance of electrical equipment. Article 408, which covers switchboards and panel boards, is relevant. Section 408.6 addresses grounding and bonding. Subsection B specifically discusses clearance. For operating handles, the NEC mandates not less than 1 inch or 25 mm from any energized part. This clearance helps prevent accidental contact during operation. When considering working space, the NEC requires not less than 12 inches or 305 mm in front of the contactor and not less than 6 inches or 152 mm behind it. These clearances provide sufficient room for electricians to safely work on the equipment. Article 430 focuses on motors, motor circuits, and controllers. Section 430.10 outlines general requirements for controllers. Subsection B emphasizes enclosures, stating that contactors shall be enclosed in cabinets or cut-out boxes. The enclosure must be sized to provide the required clearance space. This ensures that the contactor is protected from environmental factors and that there is enough room for heat dissipation and maintenance. Another important consideration is NEC 110.26. Subsection A 1 specifies that working clearances shall not be less than those required by the electrical equipment being installed. This means that the clearance around the contactor must meet or exceed the minimum requirements specified by the NEC and the manufacturer. Always consult the manufacturer's instructions for the specific contactor. Manufacturers often provide additional clearance requirements based on the design and operating characteristics of their equipment. These instructions should be followed carefully to ensure safe and reliable operation. If the existing junction box, J-box, is not large enough to provide the required clearance, an enlarged enclosure must be installed. There are several options to consider. Firstly, install a larger J-box. Select a J-box that is large enough to accommodate the contactor and provide the required clearance space. This is often the simplest solution, especially if the existing J-box is only slightly too small. Secondly, use a separate enclosure. Install a separate enclosure, such as a small panel board or cabinet, to house the contactor. This option is suitable if the existing J-box cannot be easily replaced or if additional space is needed for other components. Thirdly, remotely mount the contactor. Mount the contactor outside the J-box using a surface mount or flush mount enclosure. This approach can be useful if space inside the J-box is limited or if the contactor needs to be located in a more accessible area. When selecting an enclosure, consider the environmental conditions. If the contactor is installed in a damp or corrosive environment, choose an enclosure that is rated for those conditions, such as a NEMA 4 or 4X enclosure. Also, ensure that the enclosure is properly grounded to provide a safe path for fault current. The size of the conductors connecting to the contactor must be adequate for the load. Consult NEC Table 310.15b16 to determine the appropriate conductor size based on the ampacity of the circuit. Also, the overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors and the contactor. Refer to NEC 430.52 for guidance on sizing overcurrent protection for motor circuits. When making connections to the contactor, use appropriately sized connectors and ensure that they are properly tightened. Loose connections can cause overheating and arcing, which can lead to equipment failure and fire hazards. Always follow the manufacturer's instructions for making connections to the contactor. Before energizing the circuit, verify that all connections are tight, that the enclosure is properly closed and secured, and that all safety devices are functioning correctly. Use a multimeter to check for proper voltage and continuity. Also, visually inspect the installation for any signs of damage or defect. After energizing the circuit, monitor the contactor for proper operation. Check for excessive noise, vibration, or heat. If any abnormal conditions are observed, de-energize the circuit and investigate the cause. Regular maintenance is essential for ensuring the long-term reliability of the contactor. Inspect the contacts for wear and damage. Clean the enclosure to remove dirt and debris. Tighten all connections and verify that all safety devices are functioning correctly. Keep a record of all maintenance activities. In addition to the NEC requirements, local codes and regulations may also apply. Check with the local electrical inspector to ensure that the installation complies with all applicable codes. It's important to remember that working with electrical equipment can be dangerous. Always to energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, hire a licensed electrician. Ignoring NEC clearance requirements can lead to several problems. Firstly, it can create a safety hazard. Insufficient clearance can increase the risk of electrical shock or arc flash, which can cause serious injury or death. Secondly, it can violate electrical codes. Non-compliance with electrical codes can result in fines, penalties, and the rejection of the installation. Thirdly, it can void the warranty on the equipment. Many manufacturers require that their equipment be installed in accordance with the NEC and their own instructions in order to maintain the warranty. Fourthly, it can reduce the reliability of the equipment. Insufficient clearance can lead to overheating, premature failure, and reduced lifespan. Lastly, it can increase the risk of fire. Overheated components and loose connections can create a fire hazard, which can cause significant property damage and endanger lives. To summarize, upgrading to a NEMA size 4 contactor requires careful attention to NEC clearance requirements. Article 408 and Article 430 provide guidance on working space and enclosure requirements. Always consult the manufacturer's instructions and local codes. Ensure that the enclosure is properly sized, grounded, and rated for the environment. Use appropriate conductors, overcurrent protection, and connectors. Regularly inspect and maintain the equipment to ensure safe and reliable operation. By following these guidelines, you can ensure that the installation complies with all applicable codes and that the contactor operates safely and reliably for many years. Remember to prioritize safety when working with electrical equipment. Always to energize the circuit before working on any components and use appropriate personal protective equipment. If you are not qualified to perform the work, hire a licensed electrician. The NEC is updated regularly to reflect changes in technology and best practices. It's important to stay current with the latest edition of the NEC and to understand how it applies to your specific installation. Consider attending training courses or workshops to enhance your knowledge of electrical codes and safety practices. The NEC is not just a set of rules, it's a guide to safe and reliable electrical installations. By following the NEC, you can protect yourself, your property, and others from electrical hazards. A thorough understanding of electrical principles and practices is essential for anyone working with electrical equipment. Invest in your education and training to ensure that you have the knowledge and skills necessary to perform electrical work safely and effectively. Always double-check your work and verify that everything is installed correctly before energizing the circuit. A simple mistake can have serious consequences. Take your time and pay attention to detail. Electrical work is not something to be rushed. Accuracy and precision are essential for safety and reliability. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical engineer. Don't guess or assume anything. It's better to be safe than sorry. The NEC provides a framework for safe electrical installations, but it's not a substitute for good judgment and common sense. Use your knowledge and experience to make informed decisions about the installation and to identify and mitigate any potential hazards. Remember that electrical safety is everyone's responsibility. Report any unsafe conditions or practices to the appropriate authorities. By working together, we can create a safer environment for everyone. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Consult with a qualified electrician or electrical engineer for specific recommendations and guidance on your particular installation. And always refer to the latest edition of the NEC for the most up-to-date requirements. When selecting a contactor, consider the voltage and current ratings, the number of poles, and the type of enclosure. Choose a contactor that is appropriate for the application and that meets all applicable standards. The voltage rating of the contactor must be equal to or greater than the voltage of the circuit. The current rating of the contactor must be equal to or greater than the maximum current that the circuit will carry. The number of poles of the contactor must be sufficient to switch all of the conductors in the circuit. The type of enclosure must be appropriate for the environmental conditions. Also consider the control voltage of the contactor. The control voltage is the voltage that is used to energize the coil of the contactor. Common control voltages are 24 volts alternating current, 120 volts alternating current, and 24 volts direct current. Choose a contactor with a control voltage that is compatible with the control system. When installing a contactor, follow the manufacturer's instructions carefully. Ensure that the contactor is properly mounted and secured. Make all connections using appropriately sized connectors and tighten them securely. Verify that all wiring is correct before energizing the circuit. After energizing the circuit, monitor the contactor for proper operation. Check for excessive noise, vibration, or heat. If any abnormal conditions are observed, de-energize the circuit and investigate the cause. Regularly inspect and maintain the contactor to ensure that it continues to operate safely and reliably. Check the contacts for wear and damage. Clean the enclosure to remove dirt and debris. Tighten all connections and verify that all safety devices are functioning correctly. Keep a record of all maintenance activities.